Hello, class. This will be our first formal lecture for Chapter 9, which is our first unit in Chapter 4. Sorry, first chapter in Unit 4. Chapter 4 test, or Unit 4 test will be Chapters 9, which is dimensional analysis, and Chapter 10, which is sort of a quick geometry view. I do have up in, let me bring up the overview that I've got posted in Blackboard. Talk through that right quick, and then we'll get into 9.1. Now, the other thing I want to point out before I get into the actual homework is looking at the calendar, since this is the first unit in Chapter 4. Sorry, first chapter in Unit 4. Maybe it's nap time. So let me make sure I'm sharing that correctly. Okay, so one thing you have to be careful of with Unit 4 is, I'm making this video on November 10th. So that means there's basically 2 weeks before Thanksgiving. There's just, school is out for Thanksgiving. After Thanksgiving, we basically have a week to finish up note. If we're in person, we'd be finishing up notes on Monday, maybe Wednesday, do the review. And then the finals are Monday and Tuesday of that second week back. So as of the 10th, we have basically 4 weeks left in the semester. So you definitely can't get behind, because after Thanksgiving, it's pretty much just finish up what little bit you haven't finished up and then get ready for the final. Now, our final will be just exam 4. With the variety of topics we cover in this class, a comprehensive final really isn't, so it wouldn't be efficient, let me say it that way. But just be aware the semester is going to be over very quick, and so you can't get behind on your homework. All right. So let me bring up the overview page real quick. Computer's gone a little slow today. I'm sharing the screen. So what are we doing in Unit 4? Well, there's Chapter 9 is dimensional analysis, which sometimes we call it unit analysis. And then we're also going to do a quick review of the metric system, which that's its own little short video, and that will get posted today as well. The main reason we're doing unit analysis or dimensional analysis is, one, it's just a good overall skill to have. This is something I learned in 10th grade chemistry class, and it's stuck through me throughout my college career, both as a student as an instructor. And a lot of you are taking science classes, particularly chemistry. This is definitely a skill that you have to have for chemistry. We're not going to get quite as messy, I think, as the chemistry problems do, with their molar mass and converting to atoms and all that. But the process is the same. If you're an allied health student, at some point you're going to be doing drug dosage calculations, like this person weighs this amount, and they're supposed to get this much medicine per pound. Those sort of problems are all dimensional analysis. So this is a good overall skill to have for a large variety of reasons. And then for Chapter 10, since Chapter 9, that's only half of testing unit, we kind of need something to fill out the rest of the unit. So we're going to end the semester with just some basic geometry review. We're not doing any proofs. We're just doing area, perimeter, volume, basic stuff. And so for those of you that weren't as big a fan of the logic stuff and from Chapter 2 and Chapter 3, that is over and done with. We are now back into more, basically we're doing arithmetic the rest of the semester. So maybe a little bit of equation solving for the geometry stuff. So it's definitely changing styles here. So if you like the logic and set theory and sort of stuff, sorry, but we have to move on. All right. I will say for Chapter 9, once we do the 9.1 video, 9.2 and 9.3 is just converting different types of units. The area and volume, there's a little bit to talk about, but really the skills that we're going to talk about today in 9.1 are good for all of Chapter 9. So as a teacher, it feels a little bit redundant going over 9.2 and 9.3. So those videos might be a little bit shorter. Because it doesn't matter if you're changing from meters from meters to miles, or if you're changing from like grams to pounds. The process is still exactly the same. It's just we're doing slightly different units. Now there are a few different things in there, like temperature has its own formulas to deal with. But that's, chapter 9. Once you get the conversion stuff down, it's relatively, the problems are the same. So hopefully that will help. And then, like I said, in the geometry stuff, we'll do a little bit of the Pythagorean theorem, and then we'll get into perimeter, area, volume, surface area, stuff you've seen before. And so I, kind of like to start the semester, kind of like review stuff, and like ending the semester with geometry. It's sort of like, I don't know, cleansing the palate. Um, so hopefully you'll enjoy it. But it's like I said, we're not getting anything real heavy here. But it doesn't mean, particularly with the dimensional analysis, this is not useful stuff later on. Okay, so let's get into the notes for 9.1. Now for unit 4, I don't have as many um, lecture note pieces because it really chapter 9, like I said, I just have it all as all one document. So I'm not going to go through the entire document today. I'm going to do 9.2 and 9.3 as different videos to kind of split it up. And same thing with the geometry. Since the little geometry stuff goes relatively quick, it's all in one document, but I'll split it up into different videos. All right, so let's get into, oh wait, I knew there was one other thing on Blackboard before we get into the notes. There is an instructor formula sheet. And so what that instructor formula sheet is, open it up for you right here, make sure it's shared. The instructor formula sheet is basically on test 4, you're gonna be allowed 2 pages if one of your pages is this formula sheet. And so what I give you on this formula sheet for chapter 9, I basically give you the English to metric units conversions that you need. I don't give you the metric to metric or English to English. But those, I expect you to either know those or know that you might forget them and write them down on your 1 page of notes. I give you the temperature for conversion formulas, and then for geometry, I give you the geometry formulas that you'll need. Again, I'm not so big on you memorizing formulas. I'm much more about being able to use them correctly. And so what my in-person classes do is I give them this, and this is, I would say 90% of my students will do their 1 page notes on the back of this. So when it comes to your test, you will be able to have 2 pages of notes, as long, with this being one of them. If you want to write on the front of this and the back of this, that's fine. But you don't get 2 just random pages. One of them has to be uniform. The other thing is, the reason I give these is I do not recommend that you Google your conversion factors, because if you do, if their decimals are off and just a little bit, or if you use one that's equivalent but not the one MyMathLab's expecting, then that could be enough to throw your answer off. A lot of these problems in MyMathLab do have the conversions for English to metric, but if they don't, one thing you can always do, at least in the homework, is check the example, and then the conversion factors you need will be in the examples. On the test, I tried to pick it so that like all the English to metric is on the test question, I think. But that's all, but in case not, that's why you're using these. But that's where I got these conversion numbers. These are the numbers that MyMathLab uses. Like for example, 2.2 pounds is 1 kilogram. You can also say that 1 pound is like 0.45 kilograms, but that's going to give you rounding errors because it's really like 0.454545 forever. So again, if you're not using the conversion factors MyMathLab's expecting, you can get some wrong answers due to rounding error, basically. Okay. So that is, I would keep this handy throughout chapter 9 and 10. That way you get used to using it, and you know what's on it and you know what's not. All right, so let's get into the actual notes for today. So what we're going to do today is 9.1, and we're going to talk about measures of length. Yeah, we've already kind of talked about the metric system in a different video, so I'm not gonna review those topics. We're just gonna go through and do the conversions. So when we're talking about dimensional analysis, what do I mean by dimensional analysis? The basic idea of dimensional analysis is that we're converting between different units. So you can see over here, we're converting from inches to feet, from miles to feet. You know, these are all English. We get into meters to centimeters, meters to DM, which if you don't know what DM is, this is your metric prefix. D is deci. So DM would be decimeters, or if it was DAM or DAM, it would be 10 meters. So decimeter is 1/10 of a meter, decameter is 10 meters. And so again, this might be a helpful reference as you're going through the whole. So these are all either English to English or English to metric or metric to metric. We're also going to do English to metric. But that's the core idea in 9.1 is we're starting with one unit and we're converting to another. Now, big picture, when you're converting a unit, you're basically either multiplying or dividing. Like when we're going from inches to feet, we know there are 12 inches in a foot. So are you multiplying by 12 or are you dividing by 12? Well, sometimes your common sense works with this. And if you know that, well, inches are smaller than feet, so we're going to get fewer feet, you know to divide by 12. Or if you're going from, say, miles to feet, well, there's a lot more feet than there are miles, so that conversion is going to be a multiply problem. So if you can use common sense, that works on stuff that you're familiar with. If you get into things that you're not as familiar with, like the metric to metric or English to metric, or some of that like cups and quarts and pints and all that, we can take the guesswork out of it. You should never have to guess on a conversion if you're multiplying or dividing, if you follow the system that we're going to do with it. And it really comes down to fractions. Now, which I know just makes all of you happy, right? But we're not going to be adding, subtracting fractions. We're basically just going to be multiplying fractions, not even dividing fractions. And to be able to do unit conversions, to convert from one unit to another, there's three things you always have to know. And keeping them straight is important, particularly if it's a word problem. Now, if it's not a word problem, it's a little bit more basic to set up, but we're starting kind of small and working up. So one, what units are you starting? Again, for these problems, that's obvious because it's given. But with word problems, or if you're in chemistry, or if you're doing a drug dosage calculation, that's not always so obvious. But knowing where you're starting is key. What units are we trying to get? Well, again, in these problems, that's a given, but word problems not always a given. Particularly with like those drug dosage calculations that I've helped nursing students with for years. Like figuring out where we're trying to get to is like the hard part of the problem. But once you do that, that kind of tells you everything you need to do before. Same way with like physics. I've helped people with physics over the past few years, occasionally when I didn't really know like what they were doing big picture, but because of the units, I could get the unit set up right and I could help them with the math. And then the conversion factor, or we're going to use fractions, that is the connection between those. So the fact that there are 12 inches in a foot, that is what I mean by a conversion factor. And we're going to use fractions, like I said, to help us set it up so we take the guesswork out of it. All right, before we get to that, let's do a quick review. So we're going to multiply 5c over a times 7a b over 25c. So how do we multiply fractions? We did this back in test one in random spots here and there, but it's a good to review. So one of the things I hear at this point would be to cross multiply. Remember, cross multiply only works if that's an equals. Then we would do the cross multiplication. For multiplying fractions, just multiply top with top, bottom with bottom. At some point, you have to simplify. Now we're going to simplify first because that's sort of like the whole goal with the conversions. Is knowing how to, setting these up. So for example, when we're simplifying top to bottom, so that 5 will go to 25, so 5 will go to 5 once, I've done 25 5 times. We divided both of those by 5. Is there anything else we can simplify? Well, what about those C? Can't we do C divided by C? Because what is C divided by C? That is 1. So we can divide that out just like we're doing, like 4 divided by 4 is 1, 3 divided by 3 is 1. We can divide out our variables the same way. Where are there some colored pigments? So what else can we simplify? Well, just like the C's, we can simplify the A's, because what is A divided by A? That's 1. Now, is there anything else we can simplify? Well, there's no 7 in the denominator, there's no B in the denominator, there's no 5. So now we can just multiply. So multiply the top of the top, but 1 times 1 times 7 times B. And then on the bottom, we have a 5. And then, just double check, can you simplify that? Now, for our purposes, since we're dealing specifically with fractions, just keep it as a fraction. From what I've seen in MyMathLab, when we're doing these conversions, it's almost always decimals. When in doubt, if they want decimals or fractions, go to the examples answer and then do the same thing. But if they mention anything about rounding, they want the answer in decimal form. But since we're just dealing with the fraction part of this, I'm happy with leaving that 7/5 instead of, what is that, 1.4? So do it by 5. Yeah, 7.5 is 1.4. All right. The reason I'm showing you this is we're going to do the same thing with units that we're doing with the letters and the numbers. So if we have, say, inches divided by inches, those will cancel out, go to 1. We have, grams divided by grams, those cancel out, go to 1. That is how we're going to do these conversions. Well, before we jump into the conversions, let's make sure we know some of our basic ones. I always, ask this in every single one of my in-person classes, how many feet are in a mile. And most of the time, the class, people might know, not speak up, but as a whole, usually somebody in the class won't speak up and say, we don't know our whole number system very well, unfortunately, for the most part. But there are 5,280 feet in a mile. So there are 3 feet in a yard and 12 inches in a foot. And how many, so 1 m is how many, cm is centimeters. A centi means 1/100. So there are 100 centimeters in a meter. What's mm? Well, that's millimeter. So milli is 1,000. So there are 1,000 of those little millimeters in a meter. Now for the next one, 1 m is blank dm. You might have already mentioned this before, but what is D? Is it the big 10 or the small 10? Well, if it's deci, it's just D, so that would be 1/10 of a meter. Or if it was DA, that would be 10 of the meters. So 1 meter is 10 decimeters because deci is the small. Now 1 kilometer, how many meters are in a kilometer? Kilo is the abbreviation for 1,000. So there are 1,000 meters in a kilometer. Now, those are the most common ones we use. And when I said I'm not going to give you these on the test, these I expect you to know, because we use those over and over. Again, since you are allowed one side of 1 page of notes, you will be, you can write those on your own. Now, here's some more common English to metric. 1 inch is 2.54 centimeters. 1 meter is 3.28 feet. And 1 mile is 1.61 kilometers. Again, I don't want you to Google these because you could say, I think it's like 0.6. I don't remember the rest of it, but 0.6 kilometers is 1 kilometer is 0.6 miles. If you use that 0.6 kilometers of 1 mile in MyMathLab, that may be enough rounding error to throw off your answer. Okay, so let's, how do we formally do the dimensional analysis? Well, so what do you start with? What are you trying to get to? What are the conversion factors? So I know that for these, like this one, you probably already know you just divide by 12, but why do we divide by 12? Well, here's where dimensional analysis helps us. So where do you start? Well, we're starting with 42 inches. And what I want you to do is put that over 1. So make that a fraction. 42 inches over 1. Now we need a conversion. And now sometimes we're going to have more than one conversion, and we'll talk about that. And then where do we end? Well, we know we're trying to get to feet. So once we get to feet, we're done. So how do we go from inches to feet? Well, to go from inches to feet, you have to know that 12 inches is 1 foot. Now, notice I'm doing it on the side here at the moment because the question is, are we going to multiply by 12 or are we going to divide by 12? This is where fractions are your friend. So I do not want inches. So where does inches need to go on this fraction so that I can cancel it out? Well, if inches is on top here, inches needs to be on bottom here. And now I just say that 12 inches is 1 foot. So make sure that you have those numbers with the right ones. Now, the whole reason we're doing that is now inches divided by inches cancels it out. We're left with just feet. Well, do we need anything else? No, because feet is what we're trying to find. So now what you do is, now that we simplified, multiply. So do 42 times 1 foot. So that would be 42 feet over 12. Now this is where, like I said, I'm pretty sure MyMathLab is I'm used to everything with decimals when it comes to versions. That would be 3.5 feet. At the end of the video, I'm going to bring up MyMathLab and we'll double check on the fractions versus decimals. But we'll just say, when in doubt with conversions, put decimals on the test. I'll be more than happy if you do everything in decimals on the conversions, unless the problem explicitly mentions fractions. All right, relatively straightforward, right? So how about some bigger numbers here? We want 6.8 miles, 2 feet. We're going to start with 6.8 miles, so put that over 1. Now, how do we convert miles to feet? What do we know? Well, we should know that 1 mile, and again, for mile, make sure to use MI, not M, because that would be meters. It's 5,280 feet. So now we're going to set up a fraction and figure out if we're more to multiply or divide. I know a lot of students like to start at the top, but for me, when we're doing conversions, it's the denominator that's really important because we're trying to convert from miles to feet. So where does miles need to go on this fraction? Well, it needs to go on the bottom, so that way they cancel out. And now what do we know? We know 1 mile is 5,280 feet. Not cancel. So now you're just multiplying, so it'll be 6.8 times 5,280 feet. Now you don't have to write this step in your notes or in on your own, but I'm just doing that for the notes. So 6.8 times 5280 is 35,904 feet. So 6.8 miles is almost 36,000. Now these are all what I call one step conversions. Let's do one that may not be one step. So look at number 8. We have 10 yards, 2 inches. Now, depending on how comfortable you are with that, you may have that number pop into your head right away. How many inches are in a yard? But let's do this. Let's assume that we don't know that there's 36 inches in a yard. So how would we get to this answer? Well, we know we're starting with 10 yards. So now over here, we need on our conversions. If you don't know the direct one, then you have to kind of go step by step. And you can either start at the start and you kind of work that way, or you can start at the end. Sometimes, picking for longer problems, you kind of work it both ways. So what do we normally convert yards to? Well, 1 yard is 3 feet. Well, how does that help us? Well, now we know feet to inches, so 1 foot is 12 inches. So basically, we're kind of chaining these together. So we're using feet as an intermediate step to go from yards to inches. Now, how do we set all this up? So for my first conversion fraction, so I'm trying to convert from yards. So that means yards needs to go on the bottom. And what do I know about yards? 1 yard is 3 feet. But we can't stop because we have feet right now. We need inches. So we need another fraction. Well, what do we do here? Well, again, we're trying to get rid of feet. So feet's on top, so we need to go on bottom now. Now, what do we know about feet? Well, 1 foot is 12 inches. Feet cancel out. We're left with inches, which is what we're trying to find. So we don't need any more conversion fractions. Now we just do the fraction work. We have to multiply everything on top. We're doing 10 times 3 times 12 inches all over 1. And this is important, particularly if there's multiple numbers on the bottom that are not 1, because if you're not, if there's like 2 numbers on the bottom, if you're just going on your calculator, not being careful with it, like using the fraction button or using parentheses, you would do like this number and then you would divide by this number and then divide by this number and think you're getting the right answer. But what the calculator would do is you're supposed to divide by both of these. But in your calculator, if you do all the times and then 2 divides, they'll do that first divide, get an answer, and then divide by this. So you actually end up multiplying. It's how to say this. You're violating order of operations. Is what's going to happen if you're not careful. That's why I always like to multiply everything on top, multiply everything on bottom, and then do the division last, just to avoid any arithmetic issue. So that is what 3 times 12 is 36 times 10. That would be 336. Sorry, 360 inches. All right, so this is a 2-step conversion. And so like if you're in chemistry, you can do like 3 or 4 steps sometimes. So we'll do a couple of longer ones. So just be aware, sometimes you're gonna have to chain your conversions. There's not always an immediate one jump from one conversion to another. All right. But again, if like, especially like inches to feet, you may not need to do all this. But it's when you're dealing with messier problems, having the setup is helpful. And again, this is when I'm helping chemistry students convert like moles of this molecule to moles of this molecule into atoms. This is exactly what we're doing, is we're setting up these fractions and going through all the units like this. So what are some other problems? Let's do some metric. So 2.56 meters to centimeters. Okay, so we're starting with 2.56 meters. So what do we know about meters to centimeters? Depending on what you remember or don't remember, having this chart is handy again. So centimeters. So there's 100th. Centi is 1/100th of a meter. That means 1 meter, 100 centimeters. Now, when we're doing our metric conversions, we tend to not like decimals over here. So that would be the equivalent of saying 0.01 meters is 1 centimeter. But we prefer to not have decimals when we're doing the problems. It just makes everything go a little bit smoother. Yep. So how do we set up our fraction? Well, we're trying to get rid of meter, so it needs to go on the bottom on the next one. So 1 meter is 100 centimeters. Meters cancel. We're basically just doing 2.56 times 100, which this is where we're talking, if you do that arithmetic, you're multiplying by powers of 10, you're just moving the decimal. This is actually, if you're comfortable with that, great. If not, go on the calculator, do 2.56 times 100, you're going to get 256. Good. About number 11. 14.54 meters to DM. Right, 14.54 meters over 1. So what do you know about meters and DM? Key here is the D abbreviation. So that is 1/10. So we're dealing with decimeter. So we're dealing with smaller, these are smaller than meters. So 1 meter is 10 decimeters. So how do we set that up as a fraction? Well, meter on bottom. So 1 meter is 10 decimeters. So that means we're just multiplying 14.54 times 10. It's 145.4 decimals. It doesn't matter for metric or English, the conversions still work the same. How about 12? We have 24 meters to centimeters. Sorry, yeah, 24 millimeters to centimeters. Okay, so here's the question. Do you know the direct conversion between millimeters and centimeters? If the answer is yes, you can do this in one step. But I want to practice this with more than one step. So let's see how that works in the metric system. So we know we're starting with 24 millimeters. Well, what's the common conversion for millimeters? Or milligrams or milliliters? Let's go back to the original unit. So milli is 1/1000, so these are small. So there are 1,000 millimeters in 1 meter. How does that help us? Well, now that I have meters, what's the connection with centimeters? Well, 1 meter is 100 centimeters. Again, we can chain millimeters to meters and meters to centimeters. So we need two fractions. So how do we get rid of millimeters? Well, we know 1,000 millimeters. Let's do it on bottom is equal to 1 meter. Millimeters cancel out. Now I don't want meters, I want centimeters. So meters has to go on bottom on the next one. And 1 meter is 100 centimeters. Now the meters canceled out, and we're not just centimeters, which is what we want. Now we do the arithmetic here. This is where I would multiply everything on top. So 24 times 100 over 1,000 centimeters. And then you just do the arithmetic. So multiply those first. And what's that going to give us? 2.4. Yeah, again, if we're dealing with just the metric system, where we're moving decimals around, we're not changing the numbers. Depending on how comfortable you are with that, that can be a shortcut. Otherwise, just put it in your calculator and don't worry. Don't guess. No. All right. Let's do one more of these two-step conversions. The number 13 is 6 dm to millimeters. So as we talked about before, dm is decimeters. So we know there are 10 decimeters, 1 meter. And then 1 meter is 1,000 millimeters. So if we don't know the direct conversion between what we're doing, we have to find the link. And our link, if we're in meters, the link is going to be meters. If we're in weight, the link would be grams, because this could be DG and MG. So that would be decigrams and milligrams. This could be volume, so that could be deciliters and milliliters. And these would just be liters or grams. So it doesn't matter the overall unit that we're dealing with. That's still going to be like the link when you're dealing with different prefixes. That makes sense. So how do we do this? Starting with 6 decimeters. So put that over 1. We need to get rid of decimeters. It's on the top, so it need to be on the bottom on the next one. What about that loud farther? So we know 10 decimeters is 1 meter. Now we need to go from meters to millimeters. We need to get rid of meters, so it needs to go on bottom. We know 1 millimeter is 1,000 millimeters. So now we're in millimeters. So now we're in our final, don't need any more conversions. So now you just multiply the top, multiply the bottom. So on the top, we have 6 times 1,000. On the bottom, we're dividing by 10. Again, I do those separately. 6 times 1,000, and then 10 times 1. And so our final answer would be 600 millimeters. So 6 decimeters would be 600 millimeters. All right. Which, depending on how comfortable you are with that, since a decimeter is a tenth of a meter, so that would be like 6/10 of a meter, like 2/3 of a meter almost, like somewhere between half and 2/3. And so that's 600 millimeters. Those are those little tiny marks on your yardstick that are, millimeters about the thickness of your fingernail. So that's where that's coming from. Okay. So this is metric to metric. The only difference between metric to metric and English to English is English to English has the messier conversions. Metric to metric, it's all, the conversions are always powers of 10. It's 10 of something, 100 of something, 1,000 of something, and that's it. So you're basically just like moving the decimal when you multiply and divide by powers of 10. What other conversions do we have? Well, let's look at 14. 480 miles to kilometers. So now we are going English to metric. Well, we set up the same way. We're going to start with 480. 480 miles over 1. What do we know about miles and kilometers? Well, 1 mile is 1.61 kilometers. So how do we set that up? Well, we're trying to get rid of miles, so miles needs to go on the bottom. So 1 mile. So 1 mile goes on bottom. 1.61 kilometers goes on top. So miles cancels. We're left with just kilometers. So now we're just doing 480 times 1.61. So 772.8 kilometers. So really, the process is no different than English to English or metric to metric. It's just we have a different conversion fraction. Let's see. Now you do have to be careful because like here's kilometers to miles. So how do we do that? That's still the same conversion, but here's the difference. So now we're trying to get rid of kilometers. So kilometers is going on bottom. So the 1.61 is now on bottom, 1 mile on top. So now we're dividing instead of multiplying. Again, knowing how to set these fractions up, which goes on top, which goes on bottom. Like I said, that's supposed to take the guesswork out of this. So now we're doing 11 divided by 1.61. And when it comes to the test, this is showing your work. May not seem like it, but if you get this, if you don't show any work, again on the test on something like this, and you get it wrong, you're going to get no partial credit. So show this work so I know whether or not you're setting it up right. Now here's something else. This number is 6.83222. There's definitely going to be a note in MyMathLab on rounding on this one. So if we were to round this to the nearest hundredth, the hundredth, you got to remember is the second decimal place. That's the 3. 2 says keep the 3 the same. So if we rounded that to the hundredth, that would be 6.83. So rounding still comes into play when you have a lot of decimals. If the answer is like 1 or 2, maybe 3 decimals, MyMathLab won't always tell you to round. Definitely if it's 1 or 2. But if it's long decimals like this, look for rounding in the instructions. All right. How about 4 feet to centimeters? Well, there's my cubic centimeters. For one of the games I play, I have to roll a lot of dice, so I have a whole package of those. All right, so we're doing 4 centimeters. Sorry, it's 4 feet. centimeters. Right, so what do we do here? Well, we know we're starting with 4 feet. So do we have a direct conversion from feet to centimeters? Now, you can, like I said, you could Google one, but here are the numbers that you're going to see in MyMathLab. You're going to see 1 inch is 2.54 centimeters, which that has the centimeters, it doesn't have the feet, or 3.28 feet is 1 meter, which has the feet, but not the centimeters. So let's do this both ways and kind of see what happens. Like, because now we have but 2 starting choices. Okay. So if we're going to use the inches to centimeters, well, I need that 1 foot is 12 inches, and then 1 inch is 2.54 centimeters. Okay, 1 inch, sorry, 2.54 centimeters. So let's use that and see what happens. Okay. So feet needs to go on bottom. So 1 foot is 12 inches. So feet cancel. Now we're trying to go from inches to centimeters. So inches is on top here. So it needs to go on bottom here. The 1 inch is 2.54 centimeters. Well, that's all multiplied because everything on the bottom is 1. 4 times 12 times 2.54. Oh, sorry, I had the previous number in there. 121.92 centimeters. What if we did it the other way? What if we used 3.28 feet? Oh, sorry. My camera turned off on my computer. I didn't know if it's still showing. The 3.28 feet is 1 meter. Okay. That's something that was also given. So how would we do that? So 4 feet over 1. So now we want feet on bottom. So 3.82 feet is 1 meter. Well, we want centimeters. So what do we need to do is we have to know that 1 meter is 100 centimeters. Feet cancel. Now 1 meter is 100 centimeters. So now the meters cancel. So now what do we do? So we multiply the top. So we get 400. On the bottom, it's just 3.28. And what do we get there? 400 divided by 3.28 is 121.95121. We normally round to the hundredths, so that would be 121.96. Notice that is not the same answer quite that we got before. It's close, but it's different. And so MyMathLab may or may not accept that. And this is where, like, this problem was in MyMathLab, I would expect that they would give you either this or this, but not both. That avoids some of the confusion. So if there is a conversion problem, and again, I'm going to bring up MyMathLab here in a bit. If there is a conversion given in the problem, make sure you use that. If they give you 2 possible conversions to start with, hopefully they'll have it set up so they can accept either one. On a test, I would definitely accept either one. But again, if you're not writing out your work, then I don't know like where you're getting it from. But this is why I say do not Google conversion factors to use in MyMathLab because those decimals can be off. And if MyMathLab's not expecting like one of these 2 answers, then it's going to count your answer wrong. There's a good chance of it. All right. So sometimes there is more than one way to get to the same answer or equivalent answer. But again, the reason that we're getting different answers is 1 inch is not exactly 2.54 centimeters. 1 meter is not exactly 3.28 feet. Both of these are rounded. We're getting answers that are close to the hundredths before they're different, but still they're not exactly the same because there's rounding in these conversions. Okay. We'll talk about that again when we get into MyMathLab. So where was okay? That's what I was looking for. Okay, so what we did so far is relatively basic, and all these were just at most two steps. Let's do some that are a little bit more interesting in terms of conversions. Now let's deal with we have miles per hour to kilometers per hour, and we're going to deal with one that goes from miles per hour to feet per second. See how that works. Okay, so number 18 is 38 miles per hour to kilometers per hour. All right, so how do we set this up? Well, so far we've been setting it up as a fraction over one. But here's what happens when you have your two units like this, like the per miles per hour, that's a division. So what you want to do, that really means 38 miles per 1 hour. That's what that miles per hour means. So if we have units that are fractions, you're going to have a unit on top and a unit on the bottom. Now we're going to kilometers per hour. So here's the question. What conversions do we need? Well, miles to hours or kilometers, what do we know there? 1 mile is 1.61 kilometers. Again, if you don't have it memorized yet, that's on your formula sheet. That is one that we use a lot. So that'll take care of the miles and kilometers. Those are both hours, so we don't actually have to deal with the hours. We just have to know like where they're at in this problem. So this one it's not as messy as it looks like. So how do we go from miles to kilometers? Well, we need miles on bottom to get it to cancel. 1 mile is 1.61 kilometers. So even though it may look a little messier, this is just like we've been doing before. So now we're doing 38 times 1.61. It gives us 61.18 kilometers per. Well, if they wanted to round it like the 10th decimal place, it'd be 61.2. So that one's not as bad as you might have thought. How about number 19? So now we're doing 60 miles per hour to feet per second. And oddly enough, this is a homework problem I probably did in class in 10th grade chemistry. I still remember this like 40 years later. And this is also why I don't like people on the road tailgating me, riding too close to my bumper. And you'll see why when we get through this. All right. So what conversions do we need? Well, we need from miles to feet. That one's pretty straightforward. So 1 mile, once you remember the number, is 5,280 feet. That's a one-step conversion. But now we're also going from hours to seconds. So how do you convert between hours and seconds? Well, if you don't know the direct conversion, what can we convert both of those to? And what's the middle ground? The middle ground is minutes. So 1 hour is 60 minutes. And then 1 minute is 60 seconds. And all that's courtesy to our ancient Babylonian friends who like our base 60 numbers, right? Okay, so how do we set this up? So we're starting with 60 miles. And again, that 60 miles per hour means 60 miles per 1 hour. Okay, so let's go ahead and deal with the miles because that's what we're used to dealing with, that one on top. So to cancel out the miles on top and miles on bottom. So 1 mile is 5,280 feet. That takes care of that. That's pretty straightforward. But what do we do with the hours now? So here's where you have to be a little bit more careful because it's something new. Well, I know that 1 mile is 60 minutes, but does that hours go on bottom or does it go on top? Well, if you put the hours on bottom, they're not going to cancel because they're both on bottom. So since our hours is starting on the bottom, then our conversion fraction has to go to the top. So 1 hour is 60. Now the hours cancel. We need minutes to seconds, so we're going to do same basic idea. 1 minute is 60 seconds. The minutes has to go on top for the minutes to cancel. Now we have feet per second, which is what we're trying to get, so we don't need any more conversions. So this is a relative, for us anyway, this is like the long conversions because there's 3 steps. If you're doing a chemistry class, you're going to do a lot of it at this level. So now what do we do? Multiply, again, in the notes, I'm going to write this out to be more explicit. We're going to multiply the stuff on the top. We're going to multiply the numbers on the bottom. Once you do, and then we're talking feet per second. Then we're going to do the division. 60 times 3,060. 60 times 60 is 3,600. Then we divide those in 88 feet per second. All right. So if you're going down the highway 60 miles per hour, that's the same as 88 feet per second. And this is, I detest people riding my bumper on the highway. Because if somebody is like riding your bumper, and you've all seen this, they're on their phone. Hopefully you're not doing this, but when you go to glance at your phone, if you're like distracted for a second or two, what happens if that person in front of you had to slam on their brakes? Is like a deer ran across the road, or there's a wreck or something. In 2 seconds, that's. I mean, this is why texting and driving is bad. That's 88 feet per second. That's almost 200 feet in 2 seconds. So that's a lot of distance in a short amount of time. This is what, in case you can't tell, I'm a defensive driver. That's why people are riding my tail. And if you're one of those people, I'm going to slow down and make you either go around or go back. Because I appreciate the math and what's happening there when you're going down the highway. Okay. So that's one of the more involved conversion problems that we'll do. That's not a word problem. Because that one has, not only does it have units at the top and the bottom, which again, this is a good setup for a precursor for those you go into chemistry or allied health, but we had to do 3 conversions. And so if you're systematic in the basic problems, it makes it easier to be systematic in the more involved problems and not get lost. But those units, have to cancel out top to bottom, top to bottom, top to bottom. All right, let's see what else 9.1 has to offer. So 4 ounces to grams. Okay, so now we're not in length anymore. We're going to start like that. So hopefully by now you're like, well, what's the conversion from ounces to grams? Well, since that is when in doubt, especially that's English to metric, right? Ounces to grams. So let's go to our handy dandy formula sheet. 1 ounce is 28.3 grams. What do we do here? Well, we want to cancel ounces. So 1 ounce goes on bottom, 28.3 grams goes on top. We're just doing 4 times 28.3. 113.2. I notice I use GM. I should probably just use G. Just it's sort of a habit for me to say GM for grams. It'd be better to say G because G is the official abbreviation for grams. Well, whether or not you know it, used to the 9.3 problem. Why is that a 9.3 problem? Because grams is weight and weight is officially 9.3. But notice the process is exactly the same that we did with length. So it doesn't matter what units we're dealing with, the setup on this with the conversion factors works the same for 9.1, 9.2, 9.3. Now I'm gonna do different videos for 9.2 and 9.3, just because we're dealing with different units and like with the area and volume or something for us to talk about. But just know that if you're comfortable with what we're doing all here, you're already comfortable with the rest of chapter 9. Okay, so you can start working ahead. If not, then we're gonna do more videos to go through the rest of it. Now before we end today, let me jump into MyMathLab just to see if there's any um, different style of problems. Log back into math. If you missed my metric, I'm gonna have to. Sorry for the delay. I'm gonna have to log back into MyMathLab. But if you missed my video for just the metric system intro, one thing I did talk about there was in 9.1, there are some problems. That's just like, do you recognize like the basic metric measures? So for those of you that maybe haven't seen that yet, let me go through and show you a couple of those, and then we'll see if there's anything else. So this is from the 9.1 homework. Like here, just like, like I do definitions in some of the early ones, like here's a problem. Do you know inches to feet, feet to yards? That's a good basic question. Just help you with your conversions. A couple of those in there. Um, so there are, here's the right one. So there's definitely some basic conversions. There are a couple of problems in here. What I was looking for. Oh, this is what I was looking for. If you missed the metric system video, there are a couple questions in here. Select the best estimate or measure for the given item. So the width of an electric cord. So we're talking about half an inch, quarter of an inch, depending on what kind of cord you're talking about. So like which one of these is the best? And this is where, a meter is a yard equivalent. Electric cords are not a yard wide. A centimeter, it takes 2.5 centimeters to get an inch. All right, so that would be, so 4 centimeters would be like an inch and a half, about an inch and a half. That's a bit big, unless you're dealing with like maybe like a dryer electric cord, one of those big ones. Millimeter is, a centimeter is about the width of your pinky finger. So 4 millimeters would be about half of that. So that to me sounds fairly good. A DM, a decimeter, that's a tenth of a meter. So that's, a decimeter would be about the width of a large Kleenex box. So that would be 4 of those. So that would definitely not be the width of an electric cord. So some of these problems are just, do you have an idea of what the measures mean? So kilometers, you want kilometers when you're dealing with miles, meters when you're dealing with yards, centimeters for inches or sometimes feet. If you get really small, use millimeters. Decimeter, well, decimeter probably the closest to a foot. We don't use decimeter a lot. It's usually millimeter, centimeter, meter, kilometer. So a computer monitor, what would be measures for that? Well, what do you measure a computer monitor? I don't know about you, but I'm thinking inches. And so it's either 36 centimeters or 30. Yeah, so inches and centimeters are the closest. A decimeter, again, think 3 decimeters is a foot. So if there's 10 of those, that would be like a 30 foot. That would be way too big. Meters, that's, you're not going to get a display that's 36 yards. And then 36 millimeters, that would be like a 2 inch by 1 inch screen. So again, you're thinking inches, probably centimeters is your best choice. Okay, so there's a few of those. And then the rest of this, let me see if there's anything. And this is what I'm talking about. Notice that over here, they give you approximate English to metric conversions. So make sure that you're using, like on my page, I said 1.61 kilometers. Here it says 1.6. So in the problem, they're giving you 1.6. So use the 1.6, not the 1.61. This is where you have to be careful. And again, when in doubt, if you go to the example, they'll have the conversion in the problem for you. Like here, this one here, they want feet to meters. If you're not for sure, the one I gave you on my formula sheet was 3.28. But if you don't know, where is the see, this one doesn't actually have an example. So, but this is where that's why I'm giving you a formula sheet for all the English to metric. Right. So since it's not embedded in the problem, look to your formula sheet. This is one that you probably I'd be less likely to put this one on the test. It might show up. I prefer like putting these on the test because they have the conversions there. Right, there's more of those. And again, they're giving you so a lot of times in the English to metric. I was looking to see if there's any word problems. I think word problems are saved for 3.2 and 3.3. All right. So other than the standard um, like definitions at the beginning with knowing your conversion factors, there are a few problems where like, do you recognize what is how long a centimeter is sort of questions. The majority of the 9.1 is all the conversions like we just did. Okay. All I have for this. So next video we'll be talking about area and volume, and then 9.3 is going to be talking about weight and temperature. So those videos will be coming shortly. All right. Have a good day.